This for Math 142. This is a problem on the book out of 9.1. It's question number 81. And we're supposed to verify that this left side is equal to that right side. And what I noticed, the left side's already in terms of cosine. So I'm going to pick away at this right-hand side, try and get it in terms of cosine. So first thing I'll do is I'll square this side, multiply it by itself. So notice that that would be the same as cotangent of x minus cosecant of x times itself. So times cotangent of x minus cosecant of x. And I might just recognize it as a perfect square, do it that way. Or I could, FOIL it out, multiply it out. Cotangent times cotangent, that's cotangent squared. Negative cosecant times cotangent. And negative cosecant times cotangent. So I have two of those. Cotangent times cosecant, both of x. And then negative cosecant times negative cosecant. A negative times a negative is positive. Cosecant times itself is cosecant squared. All right. So now what I'm going to do is, this is in terms of cosine like I said before, so I'll turn all these into cosine and sine. So cotangent squared. Cotangent is cosine over sine. So this would be cosine squared over sine squared. Minus 2 of these. Cotangent, like I said, is cosine over sine. Cosecant is 1 over sine. And these are all of x. Plus, cosecant is 1 over sine. Sorry about that. So it's 1 over sine. And notice this middle term. It's 2 times this times this. So I could rewrite this middle term as negative 2 times cosine over sine times sine is sine squared. Right, that 2 is just 2 over 1, and all these fractions just multiply them all together. So basically that middle mess right there is just the same as this. All right. Now I have these three fractions all added together. And I'll write this as minus that. Just take that negative sign out of there. Notice that all these fractions have a sine squared on the bottom, so they all have a common denominator, so I can combine them all. So that means they're the same as cosine squared x minus 2 cosine x plus 1. That whole thing over common denominator, sine squared of x. And looking back to where I'm trying to get to, these are both in terms of cosine. And the top is in cosine, so the bottom, I'm going to turn it into something in terms of cosine as well. And one thing that I know about sine squared, I know this Pythagorean identity, sine squared x plus cosine squared x is 1. So if I want sine squared alone, subtract cosine squared from both sides. Oh boy, that was not a very good S. Again, subtract cosine squared from both sides, and sine squared is 1 minus cosine squared. So I can replace this with that 1 minus cosine squared x, and then everything will be in terms of cosine. So the numerator, cosine squared x minus 2 cosine x plus 1 all over 1 minus cosine squared x. And so now what I want you to notice is that all of these are like things I can factor. This is like quadratic like quadratics. So I guess the thing to kind of do in your head is to think about if cosine x was just an a, that top, let me do this in a different color. That top, that numerator would be a squared minus 2a plus 1. And the denominator would be 1 minus a squared. Right, where it's just cosine instead of a, or a instead of cosine. So this would factor to a minus 1 times a minus 1. This is difference of squares. So it would be 1 minus a times 1 plus a. And so if I you don't have to write it as a's. I just want to write it this way so you can see the form, like what I'm doing. So I'm going to factor this top. So it becomes cosine x minus 1 times itself, times cosine x minus 1 over, that difference of squares, 1 minus cosine x times 1 plus cosine x. And to keep going from there, it'd be nice if this canceled out. This is cosine minus x, this is 1 minus cosine x. So I can do a little sleight of hand here. Factor a negative 1 out of this. So if I factor a negative 1 out of this, the cosine becomes negative cosine x. Those signs are going to change. And the negative 1 becomes positive. So now that does cancel with that. And then what I end up with it in the top is negative 1 times that. So if I multiply this by negative 1, those signs are going to switch. That negative 1 becomes a positive 1. That cosine becomes a negative cosine. And this just stays 1 plus cosine. And there it is. The right side equals the left side. It's verified.